Well, hello everyone. Welcome to the first PDH Hour with Glenn in 2026. I hope everyone had a great holiday. I'm your host, Glenn Tepfer, president of CQA Solutions. And today I want to talk about basically a year in review, 2025, exposed, mind-blowing field failures, repeat offenders, and quality wins in earthwork and geosynthetics. I think it's important that we, get a feel for where we're at every year as an industry. And as a reminder, our prior webinars can be found on the CQA Solutions website. You can scan the QR code. PDH hours will only be awarded, though, for those who complete the live webinars. That's the only way we can verify who attended for the complete hour. Brief introductory outline here. The topics I'm going to go over, introduction, why I do this, construction documents, the importance and then findings, project planning, earthwork, geosynthetics, all the different stages of an installation, daily field reports, weekly meetings, certification reports, the next webinar, and then questions and answers. So as a reminder, there's a question and answer feature on the your browser. So yeah, please use that, and I'll try and address questions at the end. Hopefully we'll have a few minutes here left at the end. So introduction, why do I do this? I think it's important that we highlight areas that we need to focus on better as an industry. We also want to provide education. Some people really don't realize some of these things are issues, and you'll see that as I go through these. It's hard to believe, but some people don't realize that. So that's why I think this is important for all the parties possibly involved, from your owners, regulators, engineers, contractors, installers, CQA technicians, and even educators. We have to get the education out there, and you'll see that too as we go through it. This is a lot of this data is based on, our projects, obviously, what we see through our field CQA, constructability reviews, project audits and assessments, both during and post-construction. So we're involved in a lot of aspects, and it's a sampling of the industry, projects across the United States and even other countries from time to time. It's a small sampling, relative to all the projects going on. But if I'm seeing the stuff on our projects, what's happening on other projects out there. And then I'm going to provide some tips and recommendations along the way. And this year I added some stamps, trying to rate if I thought something improved or there was no change or got worse from last year's summary. So construction documents, this will be a review for anybody who's seen it last year. I'm going to try and move through it pretty quickly, but for those of you who are new, I left basically the same slides in here just to go over, the importance. What am I referring to by construction documents? Those are the construction plans, your technical specifications, and the CQA plan. And those are an important foundation. And they really paved the way. You have this, what I call pyramid of success. Anybody who's seen me talk or any of my presentations probably knows that I've presented this, for probably 10 years or so, but the project really starts with the owner's vision and then their involvement and accountability for that vision. And you have your design and specifications, that team of engineers, and then your materials and equipment, vendor selection, multiple places along the way, but I put it up at the top of the pyramid under the field work portion because you have your construction quality assurance and your installation contractors. That's where you see the tangible progress on the project. You can see something getting done. And a lot of times, if there's an issue, they blame it on the field work, but that's often not the case. A lot of times it stems from the construction documents, the constructability of the projects, and so forth. Construction documents, they really should mitigate your risk. And, they're the foundation, as I mentioned, of your construction success. All the documents should complement each other, and they provide a blueprint for how the project will be constructed. And, these seem like basic principles, but we're seeing it not being accomplished on a daily basis on a lot of projects. And as I mentioned, it leads to problems. Also, the importance of this guidance. These are quotes, from over the years. The owner has pushed me to the limits of my comfort in certifying this project from certifying engineers. The regulatory agency approved it. The owner isn't going to want to hear that we need additional work. So, the regulatory agencies out there, they give their blessing to something and something changes, and engineers are reluctant to do anything about it if it's changed. And then if it's not in the CQA plan or technical specifications, I can't enforce it. That's a huge one. I hear that a lot, and um, sometimes I agree with it, sometimes I don't. But, that's why we need to make sure some of this stuff is in there because we're seeing a lot of issues come out of it. Here's the different types of issues that, we've been seeing on the construction documents: cut and paste, missing information, conflicts between the documents, incorrect information, and outdated documents supplied to the CQA firm and or contractor. We've seen it both over the past year. Missing information, this I really felt like it got worse just because it seemed like we seen more of this on the projects on which we were involved, but details, batten strip details were missing on projects, specifications for the batten strip, how to attach it, how wide, what the material had to be. Then you get into your specifications and CQA plan. Here's some examples of things that we're missing, and they're not found out until construction's going on, and then it becomes an issue. Sometimes even after, because the installer does what they're used to doing somewhere else, and it doesn't really meet the intent because it wasn't in the plan. So cross seams allowed, maximum and minimum temperatures for deployment, allowable grind exposure time for the extrusion fillet welds, non-destructive test information, air pressure, beginning pressure, stabilization time, dwell time, allowable loss. One of the big reasons I think we see that in the industry, and I mentioned it in previous webinars, is a lot of people are using the drop-in specifications supplied by manufacturers, and they'll reference the ASTM, but they don't have this information in there. So you start reviewing data, and they have stuff all over the place: 4-pound pressure drop, 5-pound pressure drop, and nobody's catching it. And is it acceptable? Is it not acceptable? It's not in there. Nobody's holding anybody to a standard. That all needs to be defined. You really need to have somebody that knows what they're doing if you're using the drop-in specifications. Review it and make sure that the information is there so the project can be constructed without delays and constructed uh, properly. Vacuum test, same type of thing. And then holiday spark test, a lot of times that's even missing. It's not even mentioned as an option on a lot of projects. Excuse me. Then, we've seen too, minimum overlap of patches beyond damage. It's not spelled out. GeoNet this year, and even geocomposite, where the GeoNet is a component of the geocomposite, required overlaps are missing, and required cable tie spacing is missing. And, you get projects that have it all over the place. It might be 10-foot spacing, nothing's specified, and so it's hard to hold anybody to anything at that point. Requirements from material manufacturers, closure turf, seam direction in relation to the tufts. Uh, Requirements for the welding equipment manufacturers manuals is missing in most cases. They're not even referred to, but requiring a warm-up period for the equipment. We constantly see people turn on the generator, grab the extrusion gun and go, and there's no warm-up. And you read the manufacturer's guidance documents, and they're supposed to allow it to warm up. So, isn't an issue, isn't an issue. I think it should be spelled out, and it'll help improve quality on the projects. Conflicting information. There's no change, different information this year, I think, than what we had last year. But, dwell time, technical specs say 2 minutes, CQA plan says 5 minutes. What do you go with? Air pressure drop, 2 psi versus 4 in trial welds, 2 PO2 shear, CQA plan 5 PO5 shear. and destruct minimum frequency, 1 per 500, 1 per 1,000 lineal feet. How do people review this? How do you certify it with these differences? It just seems to raise a lot of questions, and a lot of times it causes a lot of hassle in the field, especially when the documents don't match like that, and there's a big difference. Incorrect information and practices. Earthwork, we had a project or two where, we had acres and acres of clay. One proctor was provided for a 300-acre project, and then the stockpile borrow was compiled from excavations spanning more than a decade. Geosynthetics, um, for seam destructive sample failure, capping just a seam that failed was acceptable. Last year I think we had one where cutting it out was acceptable, like the destruct failure didn't exist if you cut it out. But these failures can go beyond just a one seam, so these aren't the best specifications. Fusion machines must be calibrated 2 times a day. What does that mean? I don't know what that means because the calibration is done by the manufacturer. Maybe they mean trial welds, maybe it's a typo. But how does anybody let that go? And, it's put in there and people go through the project without catching that. Geomembrane boots are stated that they can't be non-destructively testing. And then reduced seam destructive sampling frequencies are allowed if electrical leak survey is performed. And, yeah, I got a rant on that. So, I've been saying it for years. Electrical leak locations, non-destructive testing, continuity testing, which is an electrical leak location survey, does not equal destructive testing, which is your seam strength, the total quality of the seam. They're not equal at all, and we got to get this through to people so they understand this. And I'll give my basic example, what I give in all our training classes. If you have a conductive back material, 60 mil material, your conductive formulation is going to be roughly 3%, or 2 mils on the back side there. Um, and your standard formulation is going to make up the remainder. So you could have a scratch or a gouge, down 95% or so, even more, As long as it's not touching the conductive layer, it's unlikely to complete the circuit that's going to indicate that there's a leak. So, um, your integrity, your strength of your material is going to be greatly compromised. You got a scratch that's 10%, 20%, 30%. You're not going to get the same tensile strength and elongation and break strength. And people don't realize that. And so this stuff gets, compromised because we're substituting a good technology, but we're substituting it inappropriately. Some construction practices, outdated practices that we see, topping of a failed seam is allowable in some specs, and it's largely outdated anymore because you don't want to reheat, an isolated bead here or there, we still see, but topping typically means you're going to be putting feet of extrusion down, so you might, fix 20, 30 feet of a seam or something. Improper reference to, GRI GM 19. It was changed back in 2017 to where it was broken up to A and B. And, we still see the 4 out of 5 must pass peel strength, peel separation, but the updated requirement is 5 of 5 have to pass all. And it's been that way for a while. And it's still out there, and people are still interpreting it the old way, which I think just leads to quality issues in the future. And then multiple references to discontinued ASTMs. We continue to see that throughout, the projects. Um, Construction documents, mitigating risk. This is kind of a tip here, what we suggest. The owner should maintain involvement and accountability, require peer review, and anticipate beyond the design. Is it constructible, and how's it going to, impact the project schedule? Design engineer, you really need to stop your cookie cutter process. I don't know where that went. The peer review of construction documents as a whole should be done, and then get in the field and review your design and see if there's a way of improving it. What are the problems? How can you improve it? And regulator, again, discretion on advice, see what the engineers actually know. If you're approving something, um, you know, they're gonna be reluctant to change their mind and go against what you're saying is good. Project planning, pre-construction meetings. Some of the big issues we see here is that CQA is often left out, almost always, and relevant installer personnel are left out. There's no formal agenda, no site walk, and then, you question whether parties have even reviewed the construction documents because of the aforementioned items. You see these things happening. How could that, how can we be partway into construction and be asking these questions? Impacts, like I mentioned, you get delays, increased costs. Um, an example, cold weather seaming, GRI, GM9. It's not just plug and play. People get there and we're like, oh, we're down to 32 degrees or 40, whatever your cutoff is on the specs, and they want to implement GRI, GM9, and there's things that need to be um, discussed by the engineer and approved by the engineer ahead of time. And then also in 2025, there's major revisions, but I don't see that on the website last time we checked. So, is that out there for the public? I'm not sure. Some suggestions, obviously for the pre-construction meeting, include CQA and include installation foreman, come prepared with an agenda relevant to the project, come prepared with a summary of conflicts needing to be addressed. At Palo Verde, where we had the zero leak project, I had pages and pages of notes, and they all had cross references to the CQA plan, the tech specs, RFIs, and we spent 3 or 4 hours going over it as a group with the installer, the owner, CQA, engineers, the whole team was involved. And that's how we got it to where everything was resolved for the most part before we're in the problem. You still run into some things here and there, but it was 99% resolved, and it made the project run much more efficient and increase quality. Perform a site walk with all parties. A lot of times that can help avoid, things like cutting the wrong materials at a tie-in, things like that. People need to know, what the limits are. Project planning, CQA staffing, we still have been seeing the same kind of CQA staffing issues, lack of experience, don't understand the role. There's a lot of people in the industry that don't understand the CQA role and they think it's just documentation. And there's people out there pushing, hey, we can replace CQA by data recorders, and that's not our job as CQA. Sure, we do gather the data, but the data is secondary. We have to be making sure that what's in the specs, what's in the plans, and what's in the CQA plan are being followed and done properly. And then part-time versus full-time oversight for CQA, some of the critical components like cover soils, we still see where people are covering cover soils over geosynthetics, once a week, twice a week, instead of being out there full time. And a lot of damage can occur during that time, especially wrinkles and things like that. So I'll move into earthwork here. As I mentioned earlier, as an example, we had the one site where we had one proctor to cover decades of material that had been excavated, and our people get out there and they're like, the classification doesn't even look the same, looking at a grain size just by hand, and we had a resample, and ultimately we had passing tests and things were working out, but the owner wasn't happy that we resampled, and I don't know how they couldn't have had other proctors out there and 300 acres. That's hard to imagine. Earthworks, the communications, this is kind of a new development this year that we hadn't experienced is, contractor had insufficient material for construction. The certifying engineer was on vacation and the assistant engineer, made a decision to reduce slope and the final grades. Um, so that would help accommodate the contractor and the material that was on site. But the certifying engineer luckily got back before, the construction was finished. And he said, lowering that was unacceptable and they had to bring in more material and get it all approved. But, communications and who's authorized to do what, that's critical. People all need to be on the same page and things like that shouldn't happen. Desiccation, every year this is an issue. What we're seeing is no change in it. More and more people are starting to seemingly say, oh, your subgrade doesn't have to be perfect because we're doing a leak location survey. Again, it doesn't make sense. You want your subgrade to meet the requirements. Your clay should meet the requirements. If you have a permeability requirement and you have desiccation, that top several tenths of material is probably not going to meet the permeability requirement, and it has nothing to do with a leak location. Earthwork interface issues, just we continue to see it all the time. People are, placing too dry, that lift interface where the two are bonding together, lack of scarification, moisture is added before or after, sometimes prior to the next lift placement, but it's not worked in like it should be to get a uniform moisture. And so you end up with issues. And then smoothing is another one because they run over it with the hauling equipment, the smooth tires, and it doesn't get roughed up, and you end up with smooth clay that's not bonded between lifts. Again, I mentioned earlier the desiccation. This is a big one, is no moisture conditioning on holidays. You need to add this into your plan. A lot of contractors, they take off 4th of July, Memorial Day. They don't have anybody out there watering the clay subgrade, and it gets desiccated. They come back, they add some water to the surface, roll it, and think it's all fixed, but it's not really fixed. You might not have the permeability there, and a lot of times you won't if it's sat and dried out for multiple days in the summer. Geosynthetics, moving on here to geosynthetics, start with safety. Um, on the safety, we continue to see safety guards are removed from the tools. That's one. People sometimes aren't wearing the proper PPE when they're using their utility knives, but removing these safety guards continues to be a top issue in the industry. And we want people to be safe, and this is one of the things. Another one is proper crossing of anchor trenches. I didn't put a slide in here for that, but that's another one that we see quite frequently. Nobody uses a bridge, people still jump across it, and that's a big risk for getting hurt. Communication, surprise, there's more liner crews on site the next day, and it still continues to happen. It's been better on some of our projects, but overall, feedback from people is that it's still ongoing, and you can't assume just because they put more people out there that those people know the specifications. Firsthand experience, a lot of times those crews don't know the specifications. And, I've had some major issues where they come out, they bring more people, they try and do something, and it sets them back a week because they did it wrong, and now we got to redo stuff. Geosynthetics, communications, the CQA personnel in the field, what we're seeing is they're not provided with an approved inventory list, not provided with approved panel layout drawing, so they can't enforce these things. No specification summary, or they do have one and it's missing information. Maybe it's improperly prepared. They're missing, they're improperly prepared too. We see that they're missing field equipment such as measuring instruments. They're missing their field forms. They're missing electronic tablet. If they don't have these resources, how can they do their job? They can't. And it's a shame, but we're seeing this stuff in the industry. We got to be better prepared and, rely less on the installer, and especially when you're CQA anyway. Um, we had this project here. The installer showed up early without communication. They worked on their own, began cutting the geomembrane. Turns out they cut material along the tie-in they weren't supposed to cut. And that's where it goes back to, a site walkthrough, making sure you have all the proper parties there during the pre-construction meeting. So that way this stuff can be identified. They should notify somebody if they're going to be doing work anyway on a certified project, but they didn't. Same thing, several times we had installers pull proof from the certified project we're working on, doing CQA oversight, and they went to do non-certification work elsewhere where CQA technicians weren't needed. In one case, they did this work, they used the certified material instead of pulling from the stockpile of uncertified materials. Now, that cost the owner a fortune in getting new materials that had to be certified, and delays in getting that material. Similarly, they pulled them, on a different site, and in the meantime, um, it rained and they got mud and silt in the GCO and they had to replace GCO. Again, costly mistake, and that should have been prevented. Everything should have been battened down before they left and went to the other part of the project. Insufficient ballast at the toe of the slope, we continue to see that. Same thing with the anchor trenches. Um, Rub sheets, no change here. They're rarely required on CQA plans, and a lot of times you see people aren't using the rub sheets, and a lot of this incidental damage that occurs on the geomembrane projects could be avoided with the use of rub sheets. You're not going to get it all, but everything we can reduce, the amount of damages is the amount of repairs, increases the quality of your project. And, I think, the containment sides help. If you get a spill, you don't want the gasoline or something going on the geomembrane. We've seen funky things happen with generators from time to time where they start spewing stuff. Moving on to manufacturing, we still see blemished material. I think you're always going to see blemished material just due to the construction processes. You can see a heavier texturing and some missing texturing, which can be an issue. So um, that's something we continue to see. Conformance testing, this was a new one here in 2025. The installer was responsible for getting the conformance tests, conformance samples. They sent them to the wrong laboratory, and everybody's waiting on results. And, there's a delay. They're wondering where the results are. And I guess they finally called the laboratory and they didn't have it. So it took them a while. They figured out it went to the wrong lab. And in the meantime, the owner instructed the installer to place material um, prior to obtaining all the conformance sample results because they were tired of the delay, and two rolls ended up failing and they had to be cut out. So, at least they caught it, they cut it out, and they have to replace the material, obviously. But when you cut them out of a liner system where they're already seamed, now you're going to need repairs to join them together because they're not going to fit together. And you're just typically adding more seams and more potential for quality issues when you're adding more seams to the project. Delivery and offloading and handling issues. In this case, I labeled it worse because, we had that last year, but this year, we had failing materials were delivered to a site by the same contractor. Two different sites they tried to get this failing material on. And that's just, unbelievable. At least it was caught, but, they shouldn't be doing that. They could take it to some project where they, need to use non-certified material, some material that don't matter what they're using, as long as it meets whatever requirements are there. But, it doesn't have to be an identified traceable role. They could use it there in those situations, but they try and sneak it in, and somewhere it's going to get snuck in. Somebody's going to miss it, and then what's it going to do to the project? The offloading and handling, another one here is, proper storage. There are skids under here. You can't see them, but they're under there. But they did repair the ends that were damaged to try and protect them from UV damage. They could have done a little better job, but they actually, seem to be a little better off on the projects that we were seeing, working on tarping material, protecting material, things like that. One of the big head scratchers, though, is when it comes to inventory. Inventory, yeah, no one knows how much material was ordered, and this is baffling. I mean, smaller projects, we haven't seen it as much as the larger projects. We start getting the larger projects, and somebody's got to know how much material's there. But nobody knows. You go to a weekly meeting and nobody knows. And they don't know. You start adding in, rejected material. Nobody knows the quantity of rejected. Has it been replaced? Has it not been replaced? It's insane. It doesn't make any sense. How can you even make sure you have the right amount of conformance samples if you're not tracking the material properly that's coming to the site? And we had two projects where the contractor did not order enough materials. And of course, both were, short and experienced unnecessary delays. This is a slide, I typically present in our training classes. Does the size of the generator matter? Well, of course it matters. Um, the welding equipment manufacturers, in this case, require 500 watts or more is ideal. 3,500, should be their minimum, but they do have a rating, and you need to check with the equipment manufacturer, check their manuals, and see what they are. But, we hadn't seen this one for years, but it cropped up again this year. And what happened is, they performed the trial welds with a large generator, meeting the equipment manufacturer's requirements. Then they switched to the small generator for their production seaming, and they did all their production seaming. And the owner ultimately allowed this to proceed. We went to the engineer, and the engineer went to the owner, and the owner overruled him and said he was going to allow it. And he said, we'll go by the D-struct. So the D-structs passed on the thinner LLDPE that had a lower melting point too. And, when we ran into the HDP, it was a multi-layer system with LL was the secondary and HDP was the primary. And HDP, they started getting failures. And this is the one where at one point all the destructs on this project had failed, and it was all because of these generators. Results in extra repairs and, obviously raises a concern about LLDP. This is one of the things where anybody that knows me knows that, I argue against data recorders in some instances and, not necessarily a proponent of the data recorders on everything, but this is an area where, if we were recording voltage, we could have checked that, so it's a plus there where it's something that we could use it for. Um, you can always check out some webinars last year on that, but this is a project data, 3.2 acres. We had the HDP wedge weld, original samples 21, five failures, so there was a failure rate of 24% roughly. But again, those failures were, excuse me, all the failures were all showed up at the beginning of the project. So they did switch over to a different generator, the big generator. But in the meantime, we had tracking samples on those seams. There were 15 tracking samples, 13 failures, and 87% failure rate. And if you look at the footage statistics, we had 6,500 total feet of fusion welding. Failing fusion welding was 1,000, almost 1,100 feet, so 16.7% of that failed, and that resulted in repairs. So, we suggested that they fusion weld the repairs, and they went with extrusion welding. So, total extrusion welding on the project for all the repairs and any seams was 3,000 feet, and failing fusion repair 2292. So you had 75% of extra extrusion welding because of those failures, and they could have greatly cut down that number um, had they just fusion welded with a wedge welded those in. The repairs. I mean, they should have avoided it in the first place. That would have been the best thing to do. But once we had it, so the problem's twofold. You had the failures, and then you had the extra repairs. And it was basically the owner wouldn't listen to the certifying engineer's recommendations, both for the small generator and repairs with the fusion wedge. And then the engineer didn't want to take the extrusion destructs, but we managed to talk him into taking three, and one of those failed. And it just shows you, we typically see, 15 to 20% on average failure on extrusion welds when they're taking on repairs. So a follow-up question here is, how can we change this? I mean, this is really something that needs to be discussed in the industry. How can we change this? The certifying engineer didn't want to go against the owner. Could the certifying engineer refuse to certify the project if the owner doesn't listen? How many of you are willing to do that? How many of you have what it takes to stand up to an owner and do that? When I started in the industry, I was blessed. It must have been a God thing or something because I was in a room across from the president of Hall and Associates, John Hall, and And, I was rarely in that room, but I was there and he was on a conversation with a client, a guy named Jack, I think. And, they were arguing about the project. I could hear him. It got heated. And, John ultimately said, I'm the certifying engineer. If I'm going to certify it, you're going to do it my way, or I'm not going to certify it. And they did it his way. I mean, that's all it took. But, that doesn't seem to happen. And I think that's something that needs to happen is, we need to have more of a backbone in some instances. And, you need to work with the owner, help them understand the issue, And anyway, I could rant on that, but I'm going to move on here because we'll be out of time. But, moving on to trial seams and seaming, there's a few things here. This was we occasionally see sweat dripping from the extrusion welder's forehead into the seam area. That one was new, I didn't have it last year. We hadn't seen it in a while. People were doing pretty good, we'd get moisture, but not from the sweat. And that led to some poor seams that had to be repaired. And then, fairly common is poor T-beads. You really got to keep an eye on the T-beads. Your tensiometers, we continue to see this all over. Testing with the wrong crosshead speed. In this case, was supposed to be 2 inches per minute for HDP, and they were running it at 12. And I'm not even sure what the 12 is, maybe PVC or something. I don't know offhand what the 12 is, but I think it's usually 20 for LL. But anyway, that aside, it was wrong. And, a lot of people don't catch it and it'll impact your values. And it impacts your values in the field, then you could end up with failed seams because your values were skewed. Um, Deployment, hand clamp damage, and this is an image I took from a manufacturer last year. It's still there as of yesterday, and I use it to point out, I don't think manufacturers should be, promoting bad quality, but yet they are. And you can see here, they're doing their hand clamp, and here's damage shown right there. And that happens all the time in the field because these hand clamps aren't rounded. And, we continue to see that as a big issue. And they result in, failed seams and things that go undetected. Trial welds, we see both the QA and QC don't inspect the coupons. And then the QC a lot of times don't know the required values. And part of that is nobody's relaying it to them. They're not in the pre-construction meeting. They don't a lot of times speak English, or if they do, it's poor and nobody's communicating the values to them. And so it's not necessarily their fault. I guess they should take it upon themselves to get the values, but they're moving from job to job, different material to different material. So somebody needs to make sure that it's correct. And, a lot of times it's not. Welding samples on incorrect subgrade, we consistently see that. And on the flip side, we consistently see uh, people welding on the correct subgrade. So incorrect and correct subgrade, you'll see it both. It just depends on the liner crew sometimes. And you just want to make sure that they're doing it on the correct subgrade. Here's one we continue to see too. And, a lot of people don't believe this, but installers will deliberately park their trailers sometimes where they'll do their testing and have it face away from the work so that if you're in there as a QA, you can't see what's going on. And they may run a trial weld in the middle of the day just to get, CQA, especially if you're staffed with only one or two people. It's a trick of the trade. And, we continue to see this and many times by design. So, the overheating, again, this is an issue I've been talking about, for several years, and we continue to see it. You have your overheating of the liner because it's going to pass, peel, and shear by overheating it. The remedy is to turn back the heat. And um, people don't want to do that because they risk fail and peel and shear, but we're doing more damage in the long run by overheating it. And there are some installers out there. Kudos to you guys who are doing this, but they are turning back the heat and trying to minimize it. Until we come out with some kind of better guidance in the industry regarding that. Thermal seaming, additional recommendation for extrusion. What we like to see is on our extrusion welds, we like to have the welder do a T on the destruct. You can't, or not on the destruct, on the trial weld. You can't test that T, but you can flip it over and see if there's any heat penetration issues, and you can look at how they're joining the two together. It's a good practice, only takes a couple extra minutes. Um, Again, machines, thermal fusion, the wedge welder, machines without operators, and you'll see people adjusting the seams in the machine or in the machine while in the seam. Here's a photo from last year. I didn't have any updated photos, but we catch people doing this. And, this is another good application of a data recorder. You could actually catch if somebody's tweaking the machine settings in there. And while they're in the seam, here you can see trial seam, it was this setting. 50 minutes later in the seam, it was this setting, obviously different, same machine. And that shouldn't be happening. I know you have to adjust them sometimes within the seam, for wrinkle conditions, but then, how are we justifying that that's passing? That's what we need to figure out too as an industry, because there does have to be some flexibility there. Thermal seaming, extrusion welding. Forgetting the bevel, wrong welding rod. I got some pictures of all of these off-center welds, poor grinding. Insufficient overlap was one I think that we added this year, but you pretty much see it every year. These things happen, and hopefully someday we'll get away from it, but it just depends on your crew and the experience of the installer, sometimes the motivation of the installer and type of project they're on, unfortunately. Just some pictures here for getting the bevel. You can see there's no bevel on the liner on this picture. Wrong welding rod. I forget which case it was, but they were, using LL on an HD or HD on an LL. I forget which one it was. Thermal seaming off center. We continue to see off center welds. Poor grinding. We continue to see that. These people, this is several years old photo, but we've seen stuff similar to this in the field this year, and you shouldn't be seeing that. It's sad to see that the quality hasn't improved. Reheating tees, reheating anytime you're overlapping on extrusion. You shouldn't have this conglomeration of overlapping patches. Each one of these overlaps is where they reheated the area. You're more likely to leak at these tees. You can see they probably welded over wrinkles. They might have a fish mouth in there. Um, pretty pretty shoddy work in my opinion, but they should have cut this out, get rid of the wrinkles and replace it with one big patch. And then you don't have all those overlaps, and you have just a better integrity product by not having those overlaps. Wrong equipment, we continue to see wrong gauges for air pressure testing. These have intervals of 3 psi, and we continue to see that. And it's sad, a lot of people don't catch it. We do our audits, CQA firms out there, and they're allowing this stuff, and it shouldn't be happening. They should be doing the right pressure and, recording the right results as well. Air pressure tests, this is common too. We continue to see wrong dwell times, wrong starting pressure, especially when somebody still specifies 5 psi, and a lot of the equipment, the shop vac motors can't pull that. They can only pull 2.5, 3. So the revised ASTM has 1 to 4, but some people still require the 5, and you need a Venturi system. So you'll see that a lot, or I'm sorry, I'm on the wrong one. I was on the vacuum. I thought it was on vacuum, but air pressure testing, yeah, the dwell time, the starting pressure, 30-30. You see a lot of people write that. It used to be a big issue, and it still is if they're writing 30-30. You need to verify what they have. We see people write 30 and it's 27, and, or they write 30 and it's 35. And some new air compressors can pump to the exact setting, so you need to be mindful of what equipment's out there. So I can't make the general statement 30-30 is bad anymore, but people need to be looking at it. Failing test passed by the installer, missed by the QA. Now I'm on the vacuum testing. I was looking ahead to this one, but Yeah, improper equipment. You have your um, gasket here, and it's all torn up, and you get leaks in the gasket, and it's not getting a good seal, but yet people are saying these tests pass, and a lot of it's because the operator doesn't have a clue what the leak looks like. That's a big one. We see no change. The vacuum test operator is typically going to be your lowest man on the totem pole. Um, so, uh, they don't know what they're doing. So we always recommend a blind leak, and I'll get to that in a second. We see a lot of areas missed. You can see by the imprints here that areas were missed of the scene. They weren't tested, and that's just sloppy work. But probably improper training as well. Um, and then, like I mentioned, doing a blind leak is one of our recommended practices to ensure that the technician knows at least what a leak looks like. Sometimes it's eye-opening. They never knew. Nobody told them. They've been doing it for 3 months, and their eyes are open, and it's mind-boggling to see that happen when you're out there. Destructive seam testing, this one's another one that kind of boggles your mind. To me, the requirements are meaningless. If you're just going to wheel off 500 feet and mark a destruct, it's meaningless. You're just putting extra holes in the liner. Your chances of finding a problem are much lower than if you're looking for a problem and using destructs strategically. But we've seen failing tests are not identified by the CQA engineer as well. So we suggest using the destructs wisely, minimize the frequency when possible. And then, I believe extrusion seams and repairs must be part of the sampling protocol because the failure rates are so high. And you can look at past webinars on that last year where I go into that more in depth. Some other issues we see, marking samples, I mentioned at 500 feet. This has been a big one this year. We've seen a lot of people allowing the installer to pick destruct locations when they're doing third-party CQA. We've seen a long turnaround lag time between welding and results because the installer doesn't cut them out until, 2 weeks into the project. And now you have a bunch of failures. You need quick feedback. The quicker the better. If you can get next day feedback, that's a good way to do it. Even if the larger projects where people have an on-site lab, that works great too, because you can get feedback, almost the same day or next shift. And you want that quick turnaround so you minimize the amount of failures. Then improper tracking. People just appear lost in this job. It's strange. And this is a photo from last year, but we've seen it again this year where, this is obviously they're sampling. You look at the paperwork, it's the before sampling on a failure. No repair is done to the seam. There's nothing there. They just left it. Okay, it passed. I assume it passed. I don't remember, but assuming it passed, there should be a repair going extending from this location in one direction or the other, but there's not. So what do we recommend? Using the destructs wisely, avoid critical areas such as flow lines, sumps, high stress areas. People that are wheeling off 500 foot exactly tend to stick them no matter where they fall. A place where defects already will be required. Minimize the number of additional repairs and holes by doing that, such as at intersections or, there's a burnout. If you stick a destruct next to the burnout, you don't have an extra hole. Have flexibility while meeting the requirements, ensure all operators, machines, and interfaces are represented in testing. We're seeing a lot of that this year where different issues. Either, they're only tracking it by machine and they're not paying any attention to the operator, or, interfaces are totally missed. Give the installer the option to repair something rather than um, sample at a location. Minimizing the frequency, we see, GRI, GM14 and 20 help minimize the testing frequency, but a lot of people don't implement those. And you can dive into that more in my webinars last year in February and March if you want to go back to the archives. I could go down a rabbit hole there. Wrong material and results not recognized. We're seeing where occasionally you'll get results back from labs. Laboratories are human. Sometimes they make mistakes, and you can't just be looking at the results for pass and fail. You have values, the recommended 19A, Um, 60 mil peel, I think, is 91 if I got everything right there, but assume it's 91 uh, pounds per inch as a requirement. You start seeing values in the 150s or 170s or something. You know, that's not 60 mil material. It's stronger than the yield requirements of the material. And it makes no sense, but these things happen. I've caught it where we talk to the lab on occasion and they get it right. ATV creases, unnecessary damages here. Again, ATVs, everybody has a spec in there about what the low ground pressure should be, what requirement it needs to be. Nobody has a spec other than the ones we've helped write about not driving over wrinkles. And you get these creases and they all should be repaired. They should be cut out and replaced. And these things are avoidable. Same thing with no rub sheet below the pipe clamp. We're seeing where they lay things on top of the geomembrane, and these pipes are going to move sometimes with pressure, and the liner's going to move with expansion contraction. But ultimately there's going to be damage there, and people can prevent it, but it's not being done. Post-installation damages. There needs to be a plan. Um, Fencing contractors are one of the biggest culprits I've seen doing it. So, um, but an operation and maintenance plan, have some type of follow-up plan. Improper repair methods, here they should be not welding on a wrinkle, or they should have put a patch there over the hole. You have improper extrusion methods where they should have cut here and replaced it with a circle cut. Gorilla beads, they're making a patch out of extrudate where it should have just been a patch to begin with. All these things are avoidable. Shouldn't be done. Welding over wrinkles rather than removing. It's another thing that hasn't changed in the industry. We continue to see that. A new one this year, working with appurtenances, we were called out to a site to help work on remediation from leaks that were on these pipe boots. And, the pipe boots had a lot of issues. And here's a hand clamp. And guess where that hand clamp was found? It was found inside one of the boots. Um, Over 100 leaks were identified, improper welding, multiple fish mouths, inadequate silicone, sealants, and even a hammer was found in another boot. All those things should be avoided. Batten strip, we've seen a new one this year. This isn't the photo of it, but the batten strip was not constructed properly or something. The concrete heaved and allowed water to seep in, and then it heaved worse because of freeze and thaw cycles. So not sure what the problem was there, whether it was the manufacturing or design, but something was amiss there. Final walkthroughs, they're not being performed. That's one of the big things in the industry. You want to make sure that all your materials are properly installed before the next layer is put on. And we're seeing that final walkthroughs are few and far between. Daily field reports, they seem to be worse this year when we're looking at them. There's a lot of missing daily field reports. Those days they worked, they did stuff. There's no daily field reports for them, and don't understand how. Lack of relevant data, conflicts with field data, photographs are lacking, or they even contain damaging information and they're still in there. Closure turf I had talked about earlier, which way the tufts go. And, review, that's a big one. We've seen in this case, last year it was 8 months that we had seen the review was performed up to 8 months after the day of data work. This year, the worst case we've seen was 2 months. So it's improved, but it's still bad. It needs to be done daily. And paperwork, this was a project that we took over. There were a couple, 3 weeks of work already done. This was the pile we got. And we got it from the technician on site. The engineer didn't have it. I mean, they didn't know what was being done. There was no way they were reviewing it. We found issues. This stuff needs to be organized. Earthwork, in the field reports, no lift maps, equipment's not provided, specifications aren't being followed, and placement volumes aren't being provided, so there's no way to double check quantities, no way to double check that you're using the right amount of proctors. And, I don't know why engineers and regulators aren't asking more questions in this regard. Geosynthetics, no descriptions of the processes used. Again, no quantities, no seaming, no material. And then, there's this big trend, all or partial data is obtained solely from the installer for CQA projects. And, there's even projects where CQA personnel only record part of the data. And it's just problematic. How can you track anything if you only have part of the data? How can you ensure it? It doesn't make sense to me. Weekly meetings, no one has a clue of the material quantities placed. Just I mentioned that one before. No one's tracking quality indicators. What's our pass fail rate? How much material has been placed? Do we have any trends that are concerning? So we suggest using a weekly summary report. I'll just kind of go over that real quick here because this is the same as last year. But, this is a weekly summary report. You have your materials, trial weld, seaming, destructive testing. You analyze it, look at the breakdowns, look at your failure rates, number of repairs performed, lineal feet of repairs performed. Your vacuum testing. How many leaks are you seeing on your vacuum testing? Typically, you should be finding some, or they're not doing their job more than likely. But you start getting excessive, it's a concern too. In this case, it was conductive sheet, so you have spark test. Just all you're documenting all the details, and then notes about why was material rejected, what was the cause of destructive failures. All these things are important to make decisions on, and I just kind of scrolling through them. Here suspect rule list, so you're tracking what suspect if it's sampled. Um, Weekly summary of rejected material. You want to know how many rolls were rejected, what's happening with it, what's the process. It all has to be tracked, and somebody needs to do a good job on it. People need to be held accountable. Here's a couple close-ups. I'm not going to go into them because we're running out of time, and I want to see if anybody has any questions, which is part of the reason I wanted to put these near the end. And certification reports is where we'll, really finish up here. Certification reports, hasn't changed much. We review some. The narrative doesn't match the contents of the report. Wrong cells, wrong procedures, wrong materials, missing things, incomplete. They'll contain any of the issues discussed today, but there won't be any remediation for them. It's just put in there like this was part of the process. And I'm surprised more projects aren't being rejected because of some of this stuff. And then the certification statement signed and submitted to the client and/or regulators with this information like this. And I don't understand that myself. But anyways, that's what we've seen this year. I think there's a lot that we can improve on. I'm hoping that, when I do this again next year, this time we'll have some improvement to report. We did have a little this year, and I think we just need to help each other work together to raise the bar in the industry. My next webinar, I haven't decided the topic yet. If you guys have something you want discussed that's in Earthwork, Geosynthetics, let me know sooner rather than later. I can put it together. I have a couple ideas in my head, but I'm not sure. That's going to be Thursday, February 19th, 2026 at 12:30 p.m. Eastern. So I thank you for joining me, and I'm open to taking your questions and answers. At this point, I'm trying to figure out how to end the slideshow here. Oh, is it gone? All right, I think the slideshow is gone. So yeah, let me see. There's a couple questions here I'll try and get to. Johnny asks, with regards to destructive tests, are locations on the outer crest and anchor trenches seen as representable in the effort to avoid conducting tests on critical areas of the footprint advised? I know it's a practice some people use, but I don't like using them in the anchor trench myself because I don't feel they're representative. That's either where your seam is starting or ending. The outer crest, I'm not sure what you mean by the crest, but I like to get at anything if there's, if it's going to be holding water, if there's an elevation. I like taking samples above the high water marks. Otherwise, I try and put them at intersections and things like that. And then Eddie has a question. Do you see a need for proper welder training program to avoid many of these issues? Yes, most definitely. I think, a welder training program would go a long way towards this. And not only the welder training, but, understanding exactly what the purpose of the job they're doing is and how valuable it is, an overall understanding. So, um, I'll see if there's any other questions. I don't see any other questions at this time. So, yeah.
There was one under under answered Joanna wanted me to point to.
Oh, um, yeah, I don't see. Oh, yeah, I guess. Um, yeah, someone asked if I'm sharing the PowerPoints. I gotta figure out. We usually put these on the website, so I don't necessarily share the PowerPoints unless requested to do so. We evaluate it on a case by case basis, and want to get the information out there to as many people as possible. So. Yeah, I want to thank you for joining me. Happy to be back with you in 2026 and look forward to seeing you in February. By then, I'll have it figured out what we're doing. And again, thank you very much. Bye.